Hello everyone. Thanks for joining me at the Awesome Day online conference. I'm Kwek Beng Chong, and I am a senior technical trainer with AWS. I've been with AWS for a few years and have had the opportunity to assist many of our customers in their cloud journey. Allow me to act as your guide on your first steps in your cloud journey using the AWS platform. This course is intended for individuals who seek an overall understanding of the AWS cloud, independent of specific technical roles. Upon completing this course, you should be able to define what the AWS cloud is, describe the AWS services with common use cases. Also, you should understand the AWS cloud architectural principles, the shared responsibility model, allowing you to relate them to basic security and compliance aspects of the platform. We will also be covering different pricing models and business value of adopting the AWS platform. I'm going to assume that all of you have some general IT technical as well as business knowledge. This course is broken into 5 sections. In Module 1, I will introduce AWS cloud concepts, which includes an introduction to the cloud and dive in specifically into the AWS platform. Module 2, we will introduce the AWS core services like Amazon Virtual Private Cloud, or VPC, security groups, Amazon Elastic Compute Cloud, or EC2, Amazon Elastic Block Store, or EBS, Amazon Simple Storage Service, or S3, and AWS Database Solutions. As a start, I will say the AWS service name in full, followed by the acronyms or short forms to ease you into the world of AWS terms, because after a while, it will feel like an alphabet soup of services. Moving on to Module 3, we will touch on AWS security. Here in AWS, security is job zero, and you will find that security concepts, discussions are embedded in all aspects of your interactions with AWS. Hence, it will be important to introduce to you AWS security. What is this thing called AWS shared responsibility model? How do we manage access to the AWS platform and the AWS security resources? In Module 4, we will introduce the AWS well-architected framework, which serves as a guide how to go about designing your environment on the AWS platform in secure, scalable, highly available, and cost-effective manner. Lastly, in Module 5, we will cover AWS pricing and support. Now, we will be touching on high-level pricing concepts instead of actual dollars and cents of using a particular AWS service, like the Amazon Elastic Cloud Compute or EC2. I much prefer that you head down to the pricing page of the AWS service in question to obtain the most updated information. We will briefly introduce you to the TCO calculator and the AWS support plans. As a wrap-up, we will touch on your next steps in your learning journey as you adapt the AWS platform for your organization. All right, without further ado, let's jump into the first module. If you complete watching all the 5 modules, you will receive a certificate of attendance. Please look out for it after 1 week. Let's jump into Module 1, Cloud Concepts. Let's quickly define cloud computing. Cloud computing refers to the on-demand delivery of IT resources and applications via the internet, with a pay-as-you-go pricing model. When you are using AWS, you are paying for the time that you are using the resources. For example, if you are running a Linux virtual machine for 3 hours and 40 minutes, you are only paying 3 hours and 40 minutes of usage. Hence, another common term used to describe such on-demand delivery of IT resources is utility computing, as pricing model is conceptually similar to how you are being charged for using electricity or water in your home. Before cloud computing, you would have to provision capacity based on making an educated guess of what your maximum peaks is. If you didn't meet your projected maximum peaks, you would be paying for expensive resources that would stay idle. Conversely, if you underestimate your actual maximum peaks, you have insufficient capacity to meet your needs. Mind you, this is not taking into account the overheads of real estate, power, and cooling associated with running your own data center. With AWS, you are provided a simple way to access servers, databases, storage, and higher-level application components over the internet. These resources or services can be initiated within seconds without you having to do any physical rack and stack. Any of these services is one click or an API call away. Not only can you initiate these IT resources within seconds, you can treat these as temporary and disposable resources, deprovisioning them when you do not require them, freeing you from the inflexibility and constraints of a fixed and finite IT infrastructure. By harnessing the power of AWS Cloud, your approach to change management, testing, reliability, and capacity planning is more agile and efficient. Once you have created your new AWS account via aws.amazon.com, you can sign into the AWS Management Console by this interface. You can sign in with root credentials. However, it is a security best practice to create IAM users and sign in as an IAM user together with the associated password. Once signed in, you are presented with this interface. You can explore the available AWS services, use our Solutions Builder options to quickly get started with AWS, try out our helpful tutorials and videos, investigate our helpful tips, and explore other topics all via a single click. You can also provide us with your feedback on the AWS platform, change the console display language, read our privacy policy, and our terms of use. We offer multiple methods for you to locate our services. You can view recently visited services, such as the VPC service, but remember, you can always return home by clicking the cube. There's also a handy service drop-down menu offering access to all services either by alphabetical order or by groupings of related services. You can access your account and billing information or sign out of the console from this menu. You can use the region selection menu to put your focus in the AWS region that you wish to work within for region-scoped services. The support menu provides access to the AWS Support Center, our public forums, our very comprehensive documentations, and information about AWS training and certification offerings. On the menu bar of the Management Console, you'll also find a handy pin tool that lets you drag and drop icons for your frequently used services onto the menu bar. You can reorder these icons to suit your own preferences. Click the pin again to return to normal operations. You can also remove icons if no longer required. Having set up the icons for your frequently used services, they are now only ever a click away. For each service interface, the left side typically presents a navigation menu of options. Having selected an option, you will now see a list pane for objects at the top and a details pane at the bottom, displaying details of the selected items in the list above. The interface changes according to the service that you're working with. There are controls for you to arrange the list and details pane as required. The details for the selected object are typically accessible by a number of tabs. Remember to return to the starting or home screen, just click the cube icon, which is always at the top left-hand corner. The number one reason organizations are moving to the cloud is increased agility. There are three factors that influence agility. speed, experimentation, culture of innovation. Let's take a closer look at how these factors enable organizations to be more agile by harnessing the power of cloud computing. With AWS facilities all over the world, this can offer you global reach within minutes. While it is costly to put your data centers where your customers are, well, with AWS, you can get the benefits without having to make the huge initial investment. In cloud computing, new resources are only a click away, which means you reduce the time it takes to make those resources available to your developers from weeks to just minutes, resulting in a dramatic increase in agility for your organization. Another agility benefit of cloud computing is being able to experiment more often. AWS enables operations as code in the cloud and the ability to safely experiment, develop operational procedures, and practice failure. For example, with AWS, you can spin up servers in minutes for experimenting, return or repurpose servers for other experiments. With virtual and automatable resources, you can quickly carry out comparative testing using different types of instances, storage, or configurations. Using services such as AWS CloudFormation enables you to have consistent, templated dev, test, and production environments with increasing levels of operational control. Access to low-cost resources reduces risks and encourages frequent experiments. This is great for IT because it leads to discovery of new configurations and innovations. In order to understand how AWS utilizes the agility of cloud computing, we have to look at the AWS infrastructure that supports elasticity, scalability, and reliability of cloud computing resources. Here are some examples. Elasticity in regards to elastic web scale computing, scalability in regards to scaling your fleet up or down depending on needs, reliability in regards to utilizing a highly reliable environment that AWS offers. Let's review the AWS global infrastructure, which can be broken down into 3 topics: regions, availability zones or AZs, edge locations. Those orange circles you see on the world map are AWS regions distributed across the globe, and the numbers within are the number of availability zones or AZs in that region. But what is a region? A region is a geographic area that contains 2 or more availability zones or AZs. Regions are separate entities from one another, and resources in one region are not automatically replicated to other regions. While building and choosing your custom services and features, you have the opportunity to choose in what geographical region your information will be stored. When doing so, it is important to consider which region will help you optimize latency while minimizing costs and adhering to whatever regulatory requirements you may have. Let's dive deeper here on this point. If you are leveraging cloud computing services, you can easily deploy your application in multiple regions. For instance, you can have an application in a region nearest to your headquarters in Singapore. Let's say your largest customer base is located in Melbourne, Australia. With a few clicks, you can easily deploy in the Sydney region to provide a better experience for your customers while minimizing latency and increasing agility for your organizations. All of this within minutes and with minimal cost. Given that the AWS platform has more than 105 services as of August 2018, ranging from compute, storage, security, to Internet of Things, IoT, artificial intelligence, AI, how would you choose a region if latency is not an issue? Well, head down to the AWS region table page that lists down the various AWS services available in the regions around the globe. Here, you can sort through Americas, Europe, Middle East, Africa, and finally, Asia Pacific. Notice that the table is broken down even more into specific locations and what services are currently offered there. Now, let's talk about AZs. AZs are a collection of data centers within a specific region. Each are isolated from one another, but yet they are connected together by a fast, low-latency link. So, what exactly is the benefit of having the AZs isolated but also connected? When common points of failure occur, it does not affect all of your AZs because they are isolated. How are they exactly isolated? Each AZ is a physically distinct, independent infrastructure. They are also physically and logically separated. Each AZ has their own discrete, uninterrupted power supply, on-site backup generators, cooling equipment, networking, and connectivity. They are all supplied via different grids from independent utility companies and connected through multiple Tier 1 transit providers. However, all of those details are transparent to you. From your perspective, a single AZ is equivalent to an on-premise data center. Why is this comparison important? By following the AWS best practice and provision your applications and data across 2 or more AZs, you are in effect replicating the operational principles of deploying workloads across 2 fault-isolated data centers in an on-premises design. To deliver content to end users with lower latency, as of August 2018, AWS uses a global network of 114 points of presence, 103 edge locations, and 11 regional edge caches in 56 cities across 24 countries. Regional edge caches are used to optimize caching on the edge locations so that users have a higher probability of accessing information there instead of querying the origin servers, resulting in higher latency. All of this optimization is transparent to users. Amazon CloudFront is a content delivery network, or CDN, service used to deliver content to your customers. Requests for content are automatically routed to the nearest edge location so that the content is delivered faster to the end users. Utilizing the global network of edge locations and regions, you have access to quicker content delivery. Edge locations are typically located in highly populated areas similar to regions and AZs. In addition to CloudFront, a number of AWS services leverages on the edge locations. For example, Amazon Route 53 is a highly available and scalable domain name system, or DNS, web service. AWS Shield, which is a managed DDoS protection service. And lastly, AWS WAF, which is a managed web application firewall service. Apart from increasing speed and reducing latency, one of the most important roles of an edge location is offering security at the edge before reaching your data hosted in regions. Using AWS helps customers develop high-performing and reliable solutions to address most business needs. Whether you are offering media services to customers around the world or managing medical devices for a highly decentralized workforce, AWS gives customers the tools to implement solutions quickly and with limited friction. Reliability at AWS is defined as the ability of a system to recover from infrastructure or service failures. It also focuses on the ability to dynamically acquire compute resources to meet demand and mitigate disruptions. In order to achieve reliability, your architecture and system must have well-planned foundations in place that can handle changes in demand and also detect failure and automatically heal itself. Elasticity is the power to scale computing resources up or down easily, while only paying for actual resources used. Whether you need one virtual server or thousands, whether you need computing resources for a few hours or 24/7, AWS provides an elastic infrastructure to meet your needs. The elastic nature of AWS also accommodates new strategic directions that customers want to follow. AWS offers customers innovative new services and products to utilize for their needs. With AWS, you can easily deploy your system in multiple regions around the world while providing a lower latency and better experience for your customers at minimal cost. Thanks to the efficiencies of scale that AWS enjoys, you can consistently use innovative services and cutting-edge technology without having to go through multiple procurement cycles and expensive evaluations. AWS provides capabilities to support virtually any workload. This level of innovation gives customers continued access to the latest technology. One of the key benefits for AWS customers is the ability to use services at your own pace. By using AWS and the tools AWS provides, customers can grow, shrink, and adapt their consumptions of services to meet seasonal requirements. AWS also delivers a scalable cloud computing platform designed for high availability and dependability, providing the tools that enable you to run a wide range of applications. Using AWS tools like auto-scaling and elastic load balancing, your application can scale up or down based on demand. Backed by AWS' massive infrastructure, you have access to compute and storage resources when you need them. We have come to the end of Module 1. Test your knowledge with the following questions.